All right, binomial theorem. This is Unit 7, day number 1, 2, 3, 4, 5, I believe. And it's the last day of new material. So the very last time you'll take notes on new stuff. What a bittersweet day for all of us. No, just a sweet day because we're almost there. The binomial theorem is going to help us answer or help us multiply out things like, well, there's an easy one, x plus y squared. It's like we don't need anything special to do that. We could FOIL that. Hopefully you've FOILed it enough time to know what you're going to get without having to write it out. So you'd have x squared. You'd have xy twice, so 2xy plus y squared. So that one wouldn't be too bad. But what if we had something like 3a minus b to the minus b squared to the 7th? I really don't want to, FOIL that out 7 times. Like we could, and it would still work. 3a minus b squared times 3a minus b squared. FOIL that out, get an answer. Then multiply by another one, and another one, and another one, and so on. So you could do it the long way, but long way, no thank you. That would take forever. It would work. It would just take forever. But there's an easier way called the binomial theorem. So it's going to help us, not FOIL, because we don't need it to FOIL, but help us find larger powers of, bi means 2, so if there's 2 terms raised to some power, I guess most generically it would look like this, x plus y to the nth. So if n is 1, it's super easy. I guess if n is 0, it's the easiest. If n is 2, it's not bad. 3 wouldn't even be too bad to multiply out. But if we got up to 4, 5, 6, 7, I don't want to multiply all that out. I want a shortcut way. So the binomial theorem is a shortcut. In fact, let's write out the first few lines of it and see if we can kind of get the hang of the shortcut. So write this neatly in the same way I do because it'll help see the pattern. So most of you do that anyway, but sometimes people take notes all over the place and then you won't recognize the pattern if you're all over. So x plus y to the 0, what's that equal to? 1. Okay, and I'm not going to put the 1 right next to it. I'm going to put the 1 over here a little bit, and you'll see why in a minute. How about x plus y to the first? What's that equal to? X plus y, another easy one. And again, we'll put it over a little bit. We're going to kind of center them up. It's going to end up looking like a Christmas tree. Fittingly enough. X plus y squared, we just did that one a couple minutes ago. X squared plus 2xy plus y squared. X plus y cubed. Probably should have made that a warm-up because that you could do. Just take a few minutes to multiply it all out. But you can trust me for now. It's x cubed plus 3x squared y plus 3xy squared plus y cubed. Let me put one more up there to really help us see the pattern. If we had x plus y to the 4th, what do you think the first term would be? So you probably already recognize some of the pattern. X to the 4th. Any idea what the next term would be following the pattern?
4x to the 3rd.
4x cubed. Y. Careful, just y. Now you don't know the trick for finding the next term yet, or the next coefficient, but it's 6. I'll tell you the shortcut in a minute. See if you can focus your eyes on just what the x's do in the cubic line. So don't look at anything but the x's. X cubed, x squared, x, and then nothing. X to the 4th, x cubed. How many x's do you think this one's going to have? Squared. How about y's? How many y's do you think it's going to have? Yep. 2. We're going to count up with y's and down with x's. And now we've reached the middle. Now we're going to head down the other side of the hill here. So it'll be kind of a parallel thing going on. So the 4 is back. The x's are continuing to go down. So 4x. The y's are going up. Y cubed. And then you know what the last term is going to be. Y to the 4th. All right, so we have to worry about the x's, the y's, and the coefficients. Let's talk about the x's and the y's first. Then we'll talk about where those coefficients come from. Other than the first two. The first two are easy because always 1 and then always the power. After that, a little shaky. So the power of x. It starts at n. That's its maximum value, right? So it starts at x squared or x cubed or x to the 4th. Whatever power we're dealing with, that's the first x power. And then it steps down, sort of one at a time, until there aren't any left. X to the 4, x to the 3, x to the 2, x to the 1, no x's left. And of course, if you've laid it all out right, then it works out. If you run out of x's before you get to the end, or if you've still got x squared and you think you're at the last term, then something's not right. Power of y. There's two ways to look at the power of y. You can say it does the opposite of x, right? It starts at 0 and works its way up. Or you can start at the other end. You can start at the right end and say it starts at the highest power and works its way down. So I don't know how you're going to view it, but I'm normally reading left to right, so I'm going to say that it starts at 0 and steps up to n. Take a moment and look and verify that that's the case. Look at our line 4 here. There aren't any y's, and then there's 1, 2, 3, 4 y's. And then this next statement isn't really necessary because if you get the first two statements right, the second statement is going to work every time. So it's not something you have to know. It's more of a to check type statement. Although some people end up using it to solve the problem instead of using it to check, which is fine. For each term, the powers of x and y sum or add to n, whatever the main power of the problem is. So you pick any term, x squared, y squared, 2 plus 2 is 4. This was the 4th row one. 3 plus 1 is 4. 1 plus 3 is 4. Just 4 is 4. So this is a pretty good check. I would do it using the first two. Step down your x's, step up your y's, and then if you're worried, check and make sure that they all add to 4 or 3 or 7 or whatever row you're worried about. All right, that gets us the x's and the y's. The coefficients come from Pascal's triangle. Blaise Pascal, you've heard of him in physics maybe. The units of pressure in physics are usually pascals or kilopascals. But he wasn't just a physics guy, he was also a math guy. He's also like a religious philosopher. He's got lots of interesting thoughts from Mr. Pascal. In fact, I read a quote from him last week, a couple weeks ago. He said, all of humanity's problems stem from the fact that man can't sit in a room by himself alone. I don't know if that's true or not. That seems kind of deep. But whatever, Pascal was a brilliant dude. This is Blaise Pascal. Isn't that an awesome name? It's not spelled with a Z, but still. Blaise, it's not spelled with two. Pascal. Blaise Pascal. All right, so here's enough talk about Mr. Pascal. Here's his triangle. So 1, 1, 1, and you're going to get the hang of this in a minute. 1, 2, 1. That's the x plus y squared, right? X squared plus 2xy plus y. 1, 3, 3, 1. Right now I'm just copying down the coefficients from our Christmas tree up above. 1, 4, 6, 4, 1. All right, anybody ready to guess what the next line is going to be? Oh, you can get the first two terms, I guess. 1, 5, and 5 and 1 on the back end if you're.
Is it 9 or is it
10. So you add the two above it, they combine to make the next one. So that's 10, and then that's 10, and then 5 and 1. Write the next line, see what you get, and then I'll write it and we'll see if we match. One, 6, 15, 20, 15, 6, 1. Why don't you try the next two lines and then we'll see if we match. Take a second to check those. I mean, it's just adding, so it's not really that difficult. And so if we were going to do something like x plus y to the 8th, those would be our coefficients, okay? They wouldn't just be those numbers, right? But it'd be x to the 8th, x to the 7th, x to the 6th. Count down your x's. Your y's. On the y's, remember to start at 0. Sometimes that's a trick, because people will start it at 1. But there aren't any y's on the first term, and then y 1, 2, 3, 4, 5, 6, 7, 8, and that makes sense. And then you'd have all the terms. So, binomial theorem, really ingenious way that Pascal and others figured out how to take large powers of a binomial without having to spend all day foiling and collecting like terms and regrouping and then distributing and then doing that again 7 times. So pretty cool little triangle that Mr. Pascal came up with. Let's do one example in notes and then we'll do 2 off the worksheet together. In fact, let's jump in with a little bit harder example. Let's do 2x minus y squared all to the 4th. So this is one of those tests where probably the first thing you do when you get the test is write the triangle somewhere. Well, it's not till you don't need it till the end of the test, and it's not hard to write. But at some point, you're just going to write the triangle out. And then if you have something to the 4th, you'll go find the line that has the 4 in it. and I'm going to copy those coefficients down. I'm going to space them out, though, because I know there's other stuff in there. Those are just the coefficients. So 1, 4, 6, 4, 1. Again, I'm going to space them way out, because I know I've got to stick x stuff in there and y stuff in there. All right, this one doesn't have an x, but it has a 2x. But we're going to follow the same pattern. So there's going to be 4 of them on this first term. And you're noticing I don't build this term by term. I build it coefficients, and then the x's, and then the y's. There's 3 2x's on the next term. 2 2x's on the next term. 1 2x on that term. And now I'm out of 2x's, but that's supposed to happen, right? When I get to the last term, that's exactly where I'm supposed to run out of those things. All right, the second term is negative y squared. So take the sign with it, and it's squared, but that's okay. How many negative y squareds are there on this first term? 0. Okay, so again, that's the tricky part. There aren't any on the first term. And that's why some people will start at the last term at 4 and work their way down backwards. I'm going to count up. So there aren't any on the first term. On the second term, negative y squared to the first, if you want to write it. Negative y squared to the second. Negative y squared cubed, and negative y squared to the fourth. And then, at least on the first pass, we're going to put pluses, like they're all pluses. Some of that's going to change in a minute, but when we first write it, they're all positive, and then we'll clean it up as we go. So we've done the hard work of this problem now. We did not have to multiply anything out. We didn't have to, maybe that should be the warm-up for another period, is make them do this the long way, and then we'll do the lesson and realize we get the same thing. That'd be kind of cruel, so I'm not going to do that. But you could do it the long way, and you'd end up right here. Let's clean this up a little bit. Let's see, 2 to the 4th is, I've done enough powers of 2 in here, 16. So 16x to the 4th. This next term is going to be a minus because of that negative y squared. 2 cubed, and maybe I should slow down here. 2 cubed is 8. X cubed is x cubed. We'll put the minus out front. I can still clean up the 4 and the 8, so I got one more line to go here. Minus 32 x cubed y squared. Next one, if I square 2x, I get 4x squared. This might be the most missed part of this whole problem, is when you square 2x, make sure you square the 2 and the x. What do we get when we square negative y squared? You get y to the 4th, and then there's a positive or negative. If we square a negative number, we get a positive number, so we just get y to the 4th on that one. And then clean that up a little bit. 24 x squared y to the 4th. And then, well, 4 and 2x, that's easy. If we cube a negative y, if we cube a negative, we're going to get a negative. And then power to a power, we multiply. So we end up with minus 8xy to the 6th. And then the last one, if we fourth a negative, we get a positive. So y to the 8th. So, I mean, it's a shortcut. There's still a little bit of work to do, but man, that's way easier than multiplying this thing out 4 times. I would also, a couple observations here. We said that the powers added to 4, but that's before you start your cleanup. So if something is squared inside there, they don't add to 4 every time. 4, 5, 6, 7, 8. There's still a pattern there, but they don't add to 4 each time because we didn't start with an x and a y. So be careful about using that to check. If one of them is negative, they'll end up alternating signs. Plus, minus, plus, minus, plus. You don't have to know that. It takes care of itself. But it's something to check if you remember it. All right, let's look at the worksheet and see what it asks for. So the first thing you may notice is that it doesn't ask for all of the terms. It asks for a specific term. And before we get started, let's see, they're all to the 6, 7, 5, 6. So I need Pascal's triangle to the 7th row. So I guess you could flip back and forth. You could also rewrite it up here. I don't know if there's room to rewrite it up here if you write small. Because we really need to get to the 7th row to do this worksheet. Plus it's not bad practice to write it again. Christmas tree. Perfect timing. Pascal's Christmas tree. Pascal's triangle. Okay, let's do number 1. The 4th term in the expansion of all of this to the 6th. So the first thing I see, or I want to make note of, is we're raising it to the 6th, so that means I want to be on the 6th row. Although be careful because it depends on how you count. Since we started with 0, that's kind of the 7th row, but let's call it row 6 because that's what's going to make sense. So my coefficients, well, I don't need all of them, I just need the 4th one. 1, 2, 3, 4. So my coefficient will be 20. And then my m's, again, you can write them all out, but if you know what you're doing, you can skip around a little bit. How many m's would I have on that first term? If I was going to write it all out, how many m's would there be with that first term? 6. We start with 6 and work our way down. So how many m's would be on the second term? 5. How many on the next term? And then on the term we're looking at? 3. So I'll have m cubed. And then my negative 2 n's. How many of them will be on the first term?
0.
Well, 0. You're answering the right question. 0. And then those will count up. So 0, 1, 2, 3. So negative 2n cubed. Now I'm not done. I need to clean it up and combine and whatever. But so 20 times m cubed times, careful here, if I cube negative 2, I get negative 8 n cubed. So negative 160 m cubed in m cubed and n cubed. Why don't you skip down and try number 7? Maybe follow the same pattern. You need a coefficient. You need to figure out how many y squareds there are and how many 2x's there are. So you try that one, and then we'll reconvene and see how we did. So on number 7, I want to be on the 7th row, 5th term. So there's row 7, the 5th term, 1, 2, 3, 4, 5. Will be that one. So 35 will be my coefficient. The second 35, if that really matters, I don't guess it does. Y squared. So the first term, we figure out how many of those there are. So on the first term of the 7th row, there'd be 7 of them. 7, 6, 5, 4, 3. So I should have y squared 3 of those. And then if I'm really thinking and paying attention here, I don't have to count how many 2x's should I have. If I have 3 of these, how many of these should I have? The shortcut says they add to 7. So I should have 4 of those. If I want to go count, I can. So 7th row, 5th term is right there. So the 2nd term, there's none of them. 1 of them, 2 of them, 3 of them, 4 of them. And that's what we said a minute ago. 4 2x's. So the coefficient from Mr. Pascal's triangle, and then count up for the first term, the power of the first term, count down for the power of the second term, and then just do a little bit of cleanup work. 35, y to the 6, 2 to the 4th is 16. And you will have a calculator, so when you need to do things like 35 times 16, you can do that. 560, x to the 4th, y to the 6th. So, yeah, it's a little bit of work to piece together all the things, but it's way easier than multiplying this out to the 7th power. So, pretty cool trick that Mr. Pascal came up with long ago. Alright, so your assignment is the rest of them. I'll post the odds at some point in Schoology so you can check, and obviously we'll answer questions tomorrow. You have the review worksheet, and just so you can kind of peek ahead, if you want to peek ahead, the next 2 days are both review days, so you can manage your time accordingly with whatever else you got going on in your schedule. Everything will be due on Thursday when we have the test.